I'm going to redo the first four problems that we did in this assignment, but instead of writing the domain and using inequalities, I'm going to write the domain using interval notation. So let me zoom in here. And remember, the domain, we got to pay attention to the x-axis. And we have to get the endpoints. We have to get the point that's farthest to the left, and we have to get the point that is farthest to the right. And so let's begin with the point that is farthest on the left. So if we recall, that's this point right here. So we can slice through this graph using a solid line because we have a closed point here. So we cut through this, and this is kind of like our indication that our boundary begins right here at the x value that corresponds to this point is going to be -3. So let's go ahead and record that -3. And now let's get the point that is farthest to the right. And we can see that the point that's farthest to the right is going to be this open circle. Since it's open, I'm just going to slice through it with the dotted line. And the x value that corresponds to this open circle is this +2. So remember that the domain here is from -3 to +2. This time we want to write that down in interval notation. So I have a -3 on my left bound, and then I have a +2 on my right bound. -3, remember that one was closed. For closed, we use a bracket. And then +2, that was open. For open, we use parentheses. And that is the domain in interval notation. Let's try it out on the second example. So here, we had a similar graph, or a little bit different. But again, we want to get the point that's farthest to the left. We want to get the point that's farthest to the right. So here, the point that is farthest to the left is this open circle. It's open. I'm going to slice it with a dashed line. And we can see that the x value that corresponds to this open circle is -3. So let's go ahead and record that. That's my lower bound. Now let's get the point that is farthest to the right. So the point that's farthest to the right on this graph is this one right here. And it's a closed circle, so we're going to slice it with a solid line. And the x value that corresponds to this point is actually on top of it. That's +3. Now let's go ahead and write this down in interval notation. So my lower bound is -3. My upper bound is +3. -3, my left value was open, so we're going to use a parenthesis. My right value was closed, so we're going to use a bracket. And there we have it, the domain in interval notation. Now we have to address the scenarios where we don't have any bounds, such as this one here. So remember that no point was specified on this graph here, so we're under the assumption that this one's extending forever. So we're going to draw an arrow. So we don't have a bound on the left, so we can't create a line here that represents our boundary cutting through the point that is farthest to the left. However, we can do that on the right, because on the right we do have a point that's visible to us. This point is the one that's farthest to the right on this graph, and it's closed. So let's dash, let's not dash through it, let's slice it with a solid line. And at least we know that the bound on the right is going to be +4. Okay, this x value corresponds to this dot right there. So let's go ahead and record that. And recall that here on the left, because this one's extending forever, it's going to go towards infinity. But since the x values are getting smaller, this is going to go to -infinity. So here, this is extending towards -infinity. Again, paying attention to the x values. As this extends to the left, these values get smaller and smaller to the point that they reach or they approach -infinity. So now here for interval notation, we actually take into account this concept of infinity. So here I have negative infinity on the left, and then I have a positive 4 on the right. Every time you have infinity, or some sort of infinity, you're going to use a parenthesis. So on the left, I have to use a parenthesis. And then on the right, 4 was a closed circle. So we're going to write a bracket. And that would be the interval notation, or the domain of this graph in interval notation. Let's do this one more time with this example right here. So now here on this graph, we see that on the left we have an open circle, but on the right it's not specified. So since it's not specified, we're going to be under the assumption that we have an arrow. So this segment's going to go towards infinity. And now we can get the point that's farthest to the left here. So the point that's farthest to the left is this open circle. So let's go ahead and mark it with a dashed line. And we can see that the x value that corresponds to this open circle is going to be -2. On the other hand, we're not going to be able to get the point that is farthest to the right, because this is going on forever. And as this line extends forever on the right, the x values are going to get bigger and bigger and bigger to the point that they'll approach positive infinity. So in order to record this in interval notation, we're going to get the left value, which is -2. Our right value, we're going to use the concept of positive infinity. And infinity always has parentheses, so that one's a no-brainer right there. But the -2, we have to look at it. And here we see that we have an open circle, so we're going to have to apply the parentheses. And that would be the interval notation for this graph.